Today we are going to look at generator. So you can use generator in a function such that it generates values on the fly using result one by one instead of storing them all in memory. And this is very good when you're handling big data. So we're going to look at how it works. Import system, then a function. Okay, my parameters, I start with number 0. Well, number is less than the limit. If the division is equal to 0, it means that by 2 is 0, that means that it's an even number, 1 is even number. So you number, which generate even number 1 by 1, then plus 1 until the while loop is false. So then I generate events for a very big number. Then I try to check what is the memory used to create this assignment. So SYS get size of this object bytes. So print out the memory used by generator. If I'm not using generator, I can do it by appends. So my event is empty. I start with number 0. So if number is divisible by 2 equals to the remainder is 0. So this even number, append it, then increment until it is up to limit. Return events. So again, for this one, I generate events without you, a very big number. Again, I can use this system get size of to find how many memory are used in this assignment. Can also use the function to print up to 10 numbers. If I run it, you can see that memory used by the generator is only 200 bytes. But if I'm not using generator, I'm using append and having a lot of memory used in order to store this assignment or object. So what is the application of the generator? First, it used to read large file. For example, I got a file for this file, which is a modern file. I want to see how many electrons occupied, and this given by in occup equal to 2.0 inside this file. So we've opened this file as read. For line inside the file, I script up the beginning and end of the empty space. So I want to count the operators. So start with 0 for line in read large file. If this occur in the line, so it plus 1. So this one read by line rather than read the whole file. So it save memory. The other application is to generate data on the fly. For example, you got sensors, you produce continuous string of data that need to process on the fly. So generator allow real-time processing to and respond without overwhelming the memory. So let's define a sensor data stream. So while it is true, of course, this will be always true for you. some sort of data, and then here I stimulate a delay between data acquisition. Okay, sleep for 0.5 second. So to read the data for reading in this one, so it's reading one data at a time. So if the reading is greater than 24.5, okay, this is data generated from uniform random distribution from 20 to 25. It's greater than 24.5. So you break. So we will continuously look if this number is greater than 25. The other method is you have a more simulation. Okay, you want to you generate a lot of data as time fly, but you want to look at the motion step by step without storing the large array of data. For example, is estimating a particle motion. Particle move over time given the velocity. If you have a lot of particle, then there will be a lot of data. So one way is doing is looking applying view. So you got simulate particle motion if initial position, velocity, time step, and dt time interval. So given the initial position for I in range of time step u position, then the position would be incremented by the velocity times by the time dt. So given by the initial position this, velocity this, time step this, and interval 0.1. So I can estimate position for position inside this one. It will generate one by one. Then you print data without storing a large amount of data. So running, okay, you got 261 occupied orbitals, and then sensor rating, okay, it exit 24.5, then break, and then particle position. So given by 0.1 time step, so it will generate evolution of position over time without storing large amount of data.